Okay, the first one was really fun, so let's try another one. This one has actually more than one way to do this proof, so this is a sample solution for this question. We are given that AB is congruent to AC, which really they're kind of telling us it's an isosceles triangle. Once they give us those sides, that leads me to the fact that angle B is congruent to angle C, because if two sides of a triangle are congruent, the angles opposite them are also congruent. So in this large triangle ABC, those left and right side give me the base angles. The second given is that AD is perpendicular to BC, and when I draw that in, I get right angles on both sides of segment AD. My diagram right now is already marked with angle, angle, side, so I'm set to do this proof. It's possible someone else looking at this might really want to use the reflexive property, and if so, they could use that AD is congruent to AD, and they might be doing an angle side proof in the opposite direction if they're using those base angles. Or if you missed the base angles, you could do this proof as a hypotenuse leg proof also, because the right angles give you right triangles. We have the hypotenuse, and then the reflexive property gives me the leg. Both are great options, but I'm going to go for angle side. For my side, AB is congruent to AC is given. But that side also leads me to the fact that angle B is congruent to angle C. Your reason here is if two sides of a triangle are congruent, then the angles opposite those sides are congruent. Next, I'm going to bring in my second given. AD is perpendicular to BC. This tells me that angle 1 and angle 2 are right angles. I guess I was in a little bit of a hurry and I did not put the 1 and 2 in the diagram, but this is where angle 1 is, and over here is angle 2. Now I can say angle 1 is congruent to angle 2, and the reason would be if two angles are right angles, then they are congruent. Now I have in my proof already angle, angle, and side. So I'm set to say that triangle ABD is congruent to triangle ACD by AAS congruent to AAS. Remember that once you name the first triangle, the second one has to be named so that corresponding points are in corresponding positions. This proof isn't done, however, because they asked us to prove that BD is congruent to DC. So I have to take this one step farther, and BD is congruent to DC. Our reason here is that corresponding parts of congruent triangles are congruent, or you can simply say CPCTC. Now go ahead and try it my way, or if you'd prefer, you can do this one as a hypotenuse leg proof also.